Okay, so in this video we are going to go over the review for the quadratic equations part 2 test that's going to be tomorrow. Alright, so in number 1, they are wanting us to simplify each of the radicals that they have here for us. Sorry, let me make sure this is all focused. Okay, alright, so what I'm going to do, whatever's inside of my square root here, I am going to plug that into my calculator. So I'm going to go to y equals, oops, let me get one that works. Okay. Alright, sorry about that. I'm going to go to y equals, and I am going to do the value that's inside the square root, so 20 divided by x, and then I'm going to go to the table, and what I'm looking for is a perfect number, possibly with the prime number. So here for 20 I have 4 and 5. 4 is a perfect number and 5 is a prime number, which means it can't be factored any further. So that means that this square root of 20 is equal to the square root of 4 times the square root of 5. Okay, so now since I know that I can go ahead and take the square root of this, I'm now going to simplify this to 2 times the square root of 5, and that would be my answer. Okay, so the same thing with b. I'm going to go to my calculator, and I'm going to do 75 divided by x, and go to the table, and again I'm looking for a perfect number with a prime number. So right here I see that 3 is prime and that 25 is a perfect number. So therefore I can rewrite this as the square root of 25 times the square root of 3. And now to simplify this, I'm going to take the square root of 25, which is 5, and then leave the square root of 3. Okay. Alright, same thing for 92. Go to y equals, do 92 divided by x, go to the table. So I'm looking for whenever I have a perfect number with the prime number. So right here, 4 is a perfect number and 23 is prime. So that means this equals the square root of 4 times the square root of 23. And then when I take the square root of 4, I get 2, and I just leave the square root of 23. Okay, so now for D, the only thing that's I'm going to simplify here is the radical. So it's only this piece right here. So I'm going to take the 27, that's what I'm going to put into my y equals 27 divided by x, going to the table, again looking for that perfect number and a prime number. So here it is, 3 and 9, 3 is prime, 9 is a perfect number. So that means the square root of 27 equals the square root of 9 times the square root of 3. So when I take the square root of 9, I get 3. So I can rewrite this, or I'll do this. It's 3 square root of 3. So now this will become 7 plus minus 3 square root of 3 divided by 2. So again, the only thing that's changing is the radical, what's ever being square rooted. So everything else in the setups like this will stay the same. Okay, so now let's do the square root of 8. So the square root of 8, and I'm not going to use the calculator on this one because I know that it has the perfect number 4 and a prime number 2. So I'm going to rewrite this as the square root of 4 times the square root of 2, which means this is equal to 2 square root of 2. So now I'll rewrite this as 5 plus minus 2 square root of 2 all divided by 2. And that's my answer. Okay, so now I am going to, for number 2, I'm going to solve the following by using the square root method. So remember, I have to have it where it's set up as x squared equals c, and then there might be times where it's the x plus or minus some number squared equals some number. So it looks like all of these are going to fall into this category right here. So let's look. For a, there's nothing I need to do because the x squared is by itself, so I can go ahead and take the square root of each side. So this is going to go away, so then I end up with x equals plus minus, and the square root of 64 is 8. And that's my solutions, or those are my solutions. Okay, for B, we're going to have to do a little bit of work because our x squared is not by itself. So in order to get it by itself, I'm going to divide because 4 is being multiplied here. And I want to undo the multiplication. So this goes away. So now I have x squared equals 121 121 divided by 4. And now I'm just going to square root each side. So this goes away. And my answer would be x equals plus minus 11, because the square root of 121 is 11, over the square root of 4, which is 2. All right. So for C, the same thing. This 4 is being multiplied to this x squared. So the only way that I can undo it is by division, so I can get that x squared by itself. So this goes away. So now I have x squared equals 81 divided by 4. So now I'm going to take the square root of each side. So therefore I would have that x equals plus minus the square root of 81 is 9 divided by the square root of 4, which is 2. And those are my solutions for each of those problems. All right, number 3, it says to use the square root method to find the solutions to 4 times x plus 3 squared equals 36. Okay, so just like up here, how I was saying that I want it to be set up in this format right here, because that's like, I'm going to treat this as my x squared, even though it's got a number inside of it. It's not exactly the same, but I can still take the square root of it. So I want this one to look like that. So the only thing that's different about it is that I have this 4 right here, and this 4 is being multiplied to this x plus 3 squared. So the only thing I can do to get rid of it is divide it, and what I do to one side I have to do to the other. So this goes away, and then I have x plus 3 squared equals, and 36 divided by 4 is 9. So now it's in this same format right here, so I can go ahead and take the square root of each side. So this goes away, and I have x plus 3 equals plus minus, and the square root of 9 is 3. And now I want to solve for x, so I'm just going to subtract 3 from both sides, and I get that x equals negative 3 plus minus 3. So now I need to find each of the solutions. So first I'll start with negative 3 plus 3, which gives me a 0. So right away I can tell you it's not going to be A or B. And then I have negative 3 minus 3, which is going to be a negative 6, so it can't be C. And that leaves me with D. Okay. Now, number 4 is asking which equation is equivalent to x squared plus 8x equals 4. And all of my answer options are in this format right here. So the only way that I can get this equation into this format right here is by completing the square. It's in this format that it needs to be in because my C value has to be by itself in order to do that. So now I can go ahead and get started. So remember, I'm going to be taking the B value, which is 8, and I'm going to divide that by 2, and that gives me 4. And then when I take 4 and I square it, I get 16. So I would be adding 16 here, adding 16 here, and now this perfect square trinomial is going to become x plus 4 squared, and I get that from this value right here, equals 4 plus 16 gives me 20. So I'm looking for this one, and that would be A. Okay. On number 5, what would be the value of C in the trinomial x squared minus 14x plus C in order for the trinomial to be a perfect square? So it's just like completing the square that we were doing here. I'm going to take my B value, which is negative 14, and I'm going to divide that by 2, which gives me negative 7. Then I'm going to take negative 7 and I'm going to square it, and that gives me a value of 49. So that means C equals 49. All right. Moving on to number 6. It says that Sandy solved a quadratic equation using the quadratic formula and got the answer 9 plus or minus the square root of 18 divided by 2. Which of the following shows Sandy's answer in simplified radical form? So what, again, like we did over here in the beginning, we're going to take what's inside of the square root, and that's what we're going to simplify, because that's what they've got going on here. So I know that the square root of 18 equals the square root of 9 times the square root of 2. And again, if these are not numbers that you know off the top of your head, you can always go to the y equals and do 18 divided by x and look at your table to find these values. So now when I take the square root of 9, I get 3, and I'm going to leave the 2 inside the square root. So that means my equation, when I simplify it, would be 9 plus minus 3 square root of 2 all divided by 2. So it's going to be A. Okay, number 7. It says to complete the square, then solve x squared minus 12x plus 22 equals 0 by the square root method. All right, so in order to do completing the square, I need to get my c value by itself. So the first thing I'm going to do is subtract 22 from both sides. So then I have x squared minus 12x plus my blank equals this negative 22 plus my blank. Because remember, I was subtracting 22 from both sides. So now I'm going to take my b value, which is negative 12, divide that by 2. That's going to give me negative 6. So that means this perfect square trinomial that I'm creating is going to have the factors of x minus 6 squared equals. And then I'm going to take negative 6 and I'm going to square it to get 36. So that's what goes here and here. So then negative 22 plus 36 is going to give me 14. So now coming down this way, I have, or actually now that it's in this format, I can go ahead and take the square root of each side. So this is going to go away, and then I have x minus 6 equals plus minus the square root of 14. And now I'm just going to add 6 to both sides so that I can solve for x. So I have x equals 6 plus minus the square root of 14. So that means B is what I'm looking for. Okay, so now number 8, it says solve x squared minus 1 equals negative 3x by using the quadratic formula. Okay, so in order to use the quadratic formula, remember I have to have my equation in standard form, so ax squared plus bx plus c, and I have to have it set equal to 0. So in order to get this side to be 0, I just need to add 3x to both sides. So then I'm going to have x squared minus, I'm going to put this plus 3x first, and then minus 1 equals 0. Okay, so now I'm ready to list out my A, B, and C. So A equals 1, I'm getting that right here. B equals 3, and C equals negative 1. Okay, so now I'm going to take these values, and I'm going to plug them into my formula, which if you remember is negative B plus or minus the square root of B squared minus 4AC all divided by 2A. Okay? So I know that x is going to equal negative, and my b value, which is 3, plus minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, so I know that this is going to simplify to negative 3 plus minus, and let's see what we have inside of our square root here. So all we're going to do is plug in what is in my square root. I'm not going to actually square root it. I'm just going to simplify this part right here. So 3 squared minus 4 times 1 times negative 1 gives me a value of 13. So that means I would have negative 3 plus or minus the square root of 13 all divided by 2 times 1, which gives me 2. So that means my answer would be A. All right. Number 9, according to the graph, for how many seconds is the ball in the air? Okay, so when we look at our graph, we see that this is what's telling me the seconds, right? So it starts at 0 and it goes all the way until 3 seconds. So it's going to be 3 seconds. Okay. Number 10, after how many seconds is the ball at a height of exactly 20 feet? So over here, this is telling me my feet. So here's my 20. I draw a line because we're treating it as in that y equals 20. So then I see it's intersecting at these 2 points, and it's at the x value of 0.5 and the x value of 2.5. So that means x equals 0.5 and 2.5. Okay, flipping over to the back side now. All right, number 11. The graph of a quadratic function f is shown to the right. Based on the graph, which of the following would be the best estimate of zeros of the functions? So the zeros are going to be, remember where my graph is crossing the x-axis. So I see that this one falls between -2 and -3. So it won't be that one, won't be that one. Won't be that one. It only leaves me with that one. And just to check to make sure, yeah, because this one falls between 0 and 1, so that 0.7 would work. Okay. All right, so the area of a triangle is given by the equation h squared minus h equals 12, where h is the height of the triangle in centimeters. What is the reasonable height for the triangle in centimeters? So what it means when it is asking about this reasonable height, meaning which one is going to make sense, because we might have a negative value for one of them, and it wouldn't make sense for one of our solutions, or for the solution to be a negative value, because you can't have a negative measurement. Okay, so what we're going to do first is we're going to use the quadratic formula to solve this. So I have to get my equation in standard form and set equal to 0. So I'm going to subtract 12 from both sides to get h squared minus minus 12 equals 0. So now I see that a is 1, b is -1, and c is -12. So now using the formula, I have negative in my b value, which is -1, plus minus the square root of b squared minus 4 times a times my c, all divided by 2 times my a. Okay, so let's simplify this. So these two negatives are going to give me a positive one, so plus or minus. All right, so we're going to take -1, we're going to square that, minus 4 times 1 times -12. And that is going to give me a value of 49. And 49 is a perfect number, so I can take the square root of it, which gives me 7. So I know this is going to be 1 plus or minus 7, all divided by 2. So now when I say 1 plus 7, I get 8 divided by 2, which gives me 4. And when I say 1 minus 7, I get -6 divided by 2, which gives me a -3. So again, I don't want a negative value, I want a positive one. So that means C is my correct answer. Okay, so we're going to solve the following quadratic equation using the quadratic formula. So again, I need to get this quadratic formula in standard form and set equal to 0. So in order to do that, I'm going to subtract 2x squared from both sides. So that's going to 0 out. So then I'm going to have 0 equals -2x squared plus 7x plus 11. So now let's list out our A, B, C values. So A is going to be -2, B is going to be 7, and C is going to be 11. So now we'll set it up into our formula. So I have -b plus minus the square root of b squared minus 4 times A times C, all divided by 2 times A. So this is going to be -7 plus minus. So we'll figure out what we have inside of our square root here. We have 7 squared minus 4 times -2 times 11. That gives me 137, so I have the square root of 137, all divided by 2 times -2 gives me a -4. Okay, and so now I'm going to find out what my solutions are by going ahead and doing the math for the plus and the minus. I'm going to do it all in my calculator, and I'm going to put my solutions here after I round them to the nearest hundredths place. So I know in class I was teaching y'all to that in order to divide this whole top part, by this -4. You had to put it in parentheses, but there is another way that you can do it. You can put it, do your alpha y equals inner where you have it in that fraction form, and then we can just plug in the values without the parentheses. So the first thing I'm going to do is do the addition. So it's going to be -7 plus the square root of 137 divided by -4, and that's going to give me this value right here. So I want to round to the nearest hundredth, so that means this 7 is going to become an 8 since the value next to it is a 6. So one solution is -1.18. Okay, so now to find the other solution, I'm going to do the subtraction. So again, alpha y equals inner, and then -7 minus the square root of 137, all divided by -4. And that gives me this value right here. So again, at the hundredths place, I'm going to round this up to 8 since it has a 6 next to it. So that means I would have 4.68 as my other solution. Okay, moving on to number 14. Which of the following correctly shows the quadratic formula being used for the equation? So we know this has got to be A, B, and C. And remember, this is B. But they have this as a -2, and my B value is -7, so it can't be A. Okay, so then let's see, right here they have a B, but it's not negative. But remember, when we plug in our values, we have to do negative and then a -7 since this value is negative, which would give me a +7. So this one checks out. So let's see. That means this one's not going to work. This one's not going to work. So therefore, B is my answer. And we can go ahead and check the rest of it. So you can see right here, here's my -7, my B value. Here's my A value. Here's my C value. And here's my A value again. Okay, number 15. A rectangular banner has a length that is 3 more than its width. The area of the banner is 54 feet squared. Which equation can be used to find the dimensions of the pool if W represents the width? Okay, so W is our width, and they're telling us that the length is 3 more than its width. So that means my length here is W plus 3, because when it says 3 more, that means I'm adding 3. So, and how do we find area? Length times width. So that means I would have this W plus 3 times W equals my area here, 54. So this is how we would go about finding our dimensions. So therefore it would be B. All right. Number 16. Use the method of completing the square to rewrite x squared plus 12x plus 1 equals 0. So we don't have to solve it here, we just have to have it set up in this form right here. So the first thing I need to do is get this C value by itself. So that means I'm going to subtract 1 from both sides. So then I would have x squared plus 12x plus my blank equals -1 plus my blank. So now to figure out what goes in these blanks, I'm going to take this 12, my B value, divide it by 2, and that gives me 6. So right away I know that my factors of this perfect square trinomial that I'm making is going to be x plus 6 squared equals, and now I'm going to take 6 and I'm going to square it to get 36, so that's what goes here and here. So then -1 plus 36 gives me a 35. And that's as far as I have to take it, so I look over here and I see that B is my correct answer. Okay, number 17. Using the method of your choice, solve the following equations. Okay. For number 17, since this is already set up in this way, and the only thing that is keeping it from being by itself is this 5, I'm going to subtract 5 from both sides, so that way I can use this square root method here. So let's do that. Let's subtract 5 from both sides. So then I'm going to get x plus 3 squared equals 16, because 21 minus 5 gives me 16. And now I have it set up in the way that I need to, so I can take the square root of each side. So that's going to cancel out, and then I have x plus 3 equals plus minus 4. So now to solve for x, I need to subtract 3 from both sides. So then I have x equals -3 plus minus 4. So now for my solutions, I have -3 plus 4, which gives me a 1. And then I have -3 minus 4, which gives me a -7. So those are my two solutions. Okay. So on this one right here, I'm going to use my quadratic formula. So I need to have my equation set equal to 0, so I need to subtract 8 from both sides. So then I'm going to get x squared plus 6x, and 7 minus 8 gives me a -1. So now I can see that a is equal to 1, b is equal to 6, and c is equal to -1. So now I'm ready to plug it into my formula. So I would have negative and then my b value plus or minus the square root of b squared minus 4 times my a value times my my c value, all divided by 2 times my a value, which is just 1. It's not negative. Okay, so now I am going to see what this simplifies to. So I have 6 squared minus 4 times 1 times -1. That gives me 40. So then I have -6 plus or minus the square root of 40 divided by, and 2 times 1 is 2. And I'm just going to leave it just like that. Okay. So this completes the review for our test. So as long as you have followed all the steps with me and have all this written down on your review here, and you bring it into me the day of the test, then I will most definitely give you 5 extra points. So good luck to you.